Hi, welcome back to Mr. Slover's Math. Today we're going to focus on solving systems of equations by best method. So our warm-up is to review what we did yesterday, which was solving by elimination. So remember, elimination is where you want one of your variables to disappear, to eliminate. You're looking for opposites. So a 9x and a negative 9x are opposites. One is positive, one is negative. It's a 9 and a 9. Subtract them, we get a 0x. Add going down, we get a y, we get 2. We substitute that back in. 9x plus 3 times 2 is 12. I just chose the top equation because it looked easier. You can choose whichever one you want. In this case, we did get a decimal, and that was okay. And we just wrote it as an ordered pair. So graphically, if I were to graph these, they would intersect at 2/3, 2. Okay, in order to pick best method, we need to remember what 3 options we have for solving are. So one of the methods was graphing, one of them was substitution, and one was elimination. So when is it best to use those 3? Well, it's best to use graphing when your equations are in slope-intercept form, which is the y equals mx plus b form. So y equals 3x plus 1 and y equals negative 2x minus 3. Okay, that's just an example, but you're looking for the y equals mx plus b form. That is the best way you can do it when you are graphing. For substitution, you want it when one of the variables is solved for. And it doesn't matter which variable, whether it's x equals or in this case, y equals. So because I have a y equals, and this is not set up for y equals, it's not ready to graph, I'm going to choose that. So I'm going to use substitution. And then the last one is elimination. We use this when our variables are lined up and when we have opposites, or we can either get rid of them by adding or subtracting. So here I have an opposite, a 3y and a negative 3y. Those would be opposites. So I would use elimination to solve. Now realize that you can solve all of these or any of these by any method. So this equation, I don't have to solve by graphing. I could use substitution to solve. I could use elimination to solve. It doesn't matter which option you use, you're going to get the same answer. You should get the same answer. Okay, but sometimes one method might be easier than the other, and that would be the best method. And we're going to do that in example 1. We're going to choose which one you think is the best method to solve. We're not actually going to solve. We're just going to choose which one and then defend it. Why did you say that? So 4x plus 8y equals 16, 12x minus 8y equals 32. So right away, I don't have it in slope-intercept form. So I'm not going to choose graphing. Could potentially use substitution then or elimination. But when I look closer, I have opposites in here. I have an 8y and a negative 8y. Well, those are opposites, so that means something is eliminating. So that's why I'm choosing elimination. And here's how I would defend it, just like I said. 8y and negative 8y equals 0, where I have opposites in there. Something's going to eliminate. Now, if you can't think of why you chose elimination, maybe state why you did not choose graphing or substitution. So you can always defend it that way as well. Letter B, I've got y equals x minus 3 and y equals negative 3x plus 2. I have y equals and y equals. So both of those are in slope-intercept form. So the best method would be graphing. And then letter C, if I look at both of them, my top equation is solved for y, my bottom one is not. So substitution would be your best method because one of the variables is solved for. Okay, so that's just practicing on which method to use. Once again, you can solve this equation using graphing. You can solve this equation using substitution. You can solve this equation using elimination. You get the same answer any way that you solve. It's just that elimination is the best method because it's easier for you to solve. There is less work for you. Right, the rest of the notes is you deciding which method you're going to choose and then solving. Notice I stated there is not a wrong way to solve. Each method will give you the same answer. Now, letter A is set up for graphing. However, if you chose substitution or elimination, you would get the same solution. I'm choosing graphing because it's set up for it. That's the best method. So I identify my M and my B's, and then I graph. The yellow line goes with the yellow line, goes with the yellow line. And then they intersect at 1, -1. We've graphed dozens of times, so hopefully by now you have that graphing mastered. Then the bottom equation, same thing, identify my M, my B, graph it, and where they intersect, not where they cross an axis, but where the two lines intersect, that's my solution. So in this case, it's 1, -1. Letter B is set up for elimination. So I don't need to use this graph because I didn't choose graphing. I am choosing elimination. So I'm going to add going down. I get my x's are gone. They eliminate. -9x plus 9x. 4y plus 5y is 9y. -20 plus -25 is -45. Divide by 9, get -5. Substitute it back in. X is 0. Now you may be thinking, Mr. Slover, you can't have x is 0. You can have x is 0. There's nothing wrong with that. Okay, x still represents something. It represents the lack of a group or lack of a number, right? So 0 on an ordered pair tells me we're not going right or left. We're just going to go down 5. So if you were to graph these, the two lines would intersect at 0, -5. And the other two, example 3, I have the top one by substitution and then the bottom one by elimination. Once again, you can solve these any method you want. I'm just choosing the best method, the one that it is set up for, the one that requires the least amount of work. So because I already have a variable solved, anywhere I see an x in the top equation, I'm going to plug in the -4y plus 16. And I've got my arrows to show that I'm distributing the 6 to everything in there. I underline my like terms, and I do exactly what's printed, -24 plus 7. And then I subtract 96 and divide by -17. And then letter B, I'm choosing elimination, and I'm going to subtract going down. The numbers are in red, are my work for how I got the 17 and the 17. All right, so today, it didn't matter which method you solved, whether it was graphing, substitution, or elimination, they all should give you the same answer for that system. But there is one that may be the less work, and that would be the best choice to solve. So in this one was elimination, because I have things